What's up, Math Mob? We are back at it again with another video. Today we're going to be talking about properties of equality again. I believe this time we're going to be moving from the hangers we were looking at to equations that look like the one you see on the screen. Our focus question today: how do properties of equality help write equivalent expressions and equations? So if you remember from our last lesson, we were looking at these hangers that had squares and triangles and circles on them. And we were removing shapes to keep that hanger balanced, right? When we removed two squares from one side, we had to remove two squares from the other side. And today we are going to be moving from those hangers to algebraic expressions and equations. So go ahead and start your notes and go ahead and see if you can simplify that equation that's on your screen. And when you're ready to continue, unpause the video. So you can go ahead and pause it now. Start your notes. Try simplifying that equation. And when you're ready, unpause the video and we'll continue with the lesson. Okay, some of you might be looking at that equation saying, wait a minute, that is crazy. There are letters everywhere, there's numbers, we're multiplying letters times numbers, variables times numbers, we have x, y, and z, we have parentheses there. So that's okay. We are going to take this, break it down a little bit, and find out what the simplified version of this equation is. So let's go to this first section here, just this upper right corner of the screen up here. I want you to just focus on this right now. It says figures A, B, C, and D show the result of simplifying the hanger in figure A by removing equal weights from each side. So they removed equal weights, removed, and then they finally got down to D. So the first thing I want you to do is this section here. So here are some equations, and each equation represents one of these hangers. So go ahead and see if you can match up the hanger to the equation. Okay, go ahead and take a minute to do that. Pause the video, take a minute to do that, and then we'll talk about why they match up. Okay, so you may have started with this one here. This is the hanger here. So D has two triangles and one square. And we can look at this equation here. It says 2 of something, so maybe that's y are the triangles. 2 triangles are equal to a square, and it looks like a square might be x. So yeah, this one goes with that hanger D. So let's look at this long one here. This long one, maybe that has the longest equation. I don't know. Let's see if we can match it up. So we have 2, since we know that the x's are the squares, and we know that the y's now are the triangles. Let's see if we can match this up. So this is 2 times whatever's in this group. This looks like a group of x, so a square plus 3 triangles. So we have 2 of these. So let's go over to this equation and see if we have 2 groups of a square and 3 triangles. Here is a square and 3 triangles. So there's one group, right? Do we have another group like that? Yes, we do. We do right here. So this right here is 2 times the quantity x plus 3y. That's what that is. So this, let's see, we have plus 2 of something. It looks like the z's are the circles, right? 2 circles. So z's are equal to the circles. So this is the 2z. So on this side, looks like we have 2z, so 2 circles, check, plus 4 squares, 4 times x, and we know that x is 4 squares. 1, 2, 3, 4, check, plus 2 triangles. Yep, so it looks like this one here matches up with A. So I'm going to move that over. Well, we don't have enough room here. I'm just going to put it up top and say this matches with A. So let's look at B. B, it looks like all they did was remove the 2 circles, right? From this side, it looks like they removed the 2 circles, and then we're just left with the 2 groups. The 2 groups, so yeah, this is the 2 groups of a square plus 3 triangles. And then on this side, we have 4 squares and 2 triangles, so 4 squares plus 2 triangles. It looks like that one is B. And that must mean this one is C. We have a square and 3 triangles. A square plus 3 triangles is equal to 2 squares and a triangle. 2 squares plus a triangle. So that one is C. And then D is the last one. Okay, so let's look at this last question down here. It says, explain what was done to each equation to create the next equation. So what was done here to right here to get this equation? Well, if we look at the picture, if we look at this picture, going from this picture to this picture, what's changed? It looks like they removed the circles, right? They got rid of those circles. Where are the circles? The circles are z. So they removed 2z. So on the hanger, we can just cross them out. We can just cross them out by removing them. But with an algebraic equation, we can't just cross stuff out wherever we want. So what we actually did was we subtracted the 2 circles. And we did that on each side to keep the hanger balanced, right? Or in this case, to keep the equation balanced, because this equation represents the shapes on this hanger. So we subtracted 2z, subtracted 2z, and then in equation B, the circles are gone, or the z's are now gone. So now we're at B. We know how we got there. Now, how did we get from B to C? This is an interesting one. It looks like they're just left with that. Right? From C is x plus 3y. So they removed one of the groups somehow, right? We have 2 groups, and they removed one of the groups. So did they subtract? Did they subtract a square? Did they subtract a square and 3 triangles? Well, if they only subtracted 1 square and they subtracted 3 triangles, that would be, we would have three squares left, and we'd have negative triangles on this side. So they didn't do that. They didn't subtract. They didn't add anything because stuff is missing. So what did they do? Well, what they did was they took this side and divided it in half. They divided it by 2, or multiplied by 1/2. So they took this and divided it by 2, and then they divided this whole side by 2 also. If they take everything here, they take the squares and divide them in half, and the triangles and divide them in half, then they're left with 2 squares and 1 triangle. So they divided each side by 2. Now keep in mind, they divided the whole side. They just didn't divide the squares, or they just didn't divide the triangles. They divided the whole sides by 2. So now to get from C to D, what did they do? It looks like they did a couple things in one step, right? We don't have any x's down here, so it looks like they removed the x's. So 1x minus another 1x is nothing, so that's gone. 2x minus an x, 2x's minus 1x is an x, so that's there. But now they have this 3y down to 2y. They must have subtracted a y also. So 3y minus a y is left with 2y, and y minus a y is no y's, right? So now that equation simplified is 2y is equal to x. So if we look at this equation here, this simplifies to 2y is equal to x. Okay, let's do this next activity, and I want you to do this one on your own. I want you to see if you can figure out for each of these equations, 1 through 5, starts out with 1 and then it changes to something else. And I would like you to find out what they did to each equation to get the new equation. So for example, this first one, it starts out 3x plus 7 is equal to 5x. And then it changes to 7 is equal to 2x. Did they multiply each side by negative 1/3? Or did they add negative 3x to each side? Did they add 3x to each side? Did they add negative 3 to each side? What did they do? A, B, C, D, E, or F? Yes, there's one more choice than there are equations here on purpose. What did they do to get to these equations? So go ahead and do that on your own. Pause the video, do that on your own. Then when you're ready to see the answers, unpause, and then we will look. Okay, for this one, 3x plus 7 is equal to 5x. It looks like they subtracted, remember the hangers, these are like 5 squares, right? It looks like they took away 3 squares. They took away 3x, so minus 3x. And that left us with 7 is equal to 2x. So I'm looking for subtracting 3x. Add 3x. Oh, here we go. Add negative 3x. When we add a negative, it's the same as subtracting a positive, right? So this one is B. So let's look at this one. What is happening here? Looks like they maybe subtracted 4, but they didn't subtract 4, so maybe they divided. 6 divided by 3 is 2. 3 divided by 3 is 1. 12 x's divided by 3 is 4 x's. So we are looking for dividing by 3, or, in this case, multiplying by 1/3. Multiplying by 1/3 and dividing by 3 is the same thing. So let's look at this one. This one looks like the 6x's stayed the same and the 5x's stayed the same. So what did they do? How did they get from here to here? It looks like they subtracted 3, right? 10 minus 3 is 7. Did they do the same thing over here? 4 minus 3 is 1. So they subtracted 3, or add negative 3. So it looks like that one is D. Number 4, 5x divided by 3 is equal to 12 divided by 1. Wow, what is going on here? So it looks like, how do we get from 12 to negative 36? We'd have to multiply, right? We have to multiply by a negative for sure, because a positive times a negative is a negative answer. So what number times 12 is 36? That would be 3. It looks like we're multiplying by negative 3. So is there a multiply? There is. Multiply each side by negative 3 right here, but let's make sure it happens over here too. So 5x divided by negative 3, if we're multiplying by negative 3, 5x times negative 3 is negative, well, we could just cross cancel here, right? That would be easier. So 5x times 1 is 5x. And then negative 1 times negative 1. Yeah. 1 times 1 is 1. So this is negative, multiplying by negative 3. I can't read my writing there. That's what happened. Let's see. We are multiplying by negative 3 over 1. There we go. That's clear. We cross cancel out here. Negative 1 times 1 is negative 1. 5 times negative 1 is negative 5. Negative divided by a negative is a positive. Okay, there we go. All right, that's why it's important, you guys, to write clearly so you know what you are seeing. Okay, so this one was F, multiplying each side by negative 3. So let's look at this last one. It says negative 3 times the quantity 4x minus 3 is equal to negative 15, but that changed to 4x minus 3 is equal to 5. So how is that equation changing? What are they doing to each side of that to change? Well, negative 15, if we add 20, we would get to 5, but it doesn't look like we're adding 20 on this side. So maybe we're dividing. Maybe we're dividing by what number would give us 5? If we divide 15 by 3, that would give us 5. So we'd have to divide by a negative 3 though, right? Because a negative divided by a negative gives us a positive 5. So let's see if we do the same thing over here. If we divide by a negative 3, and we can see negative 3 is on the outside of these parentheses. So that means we have negative 3 groups of this. So if we take those 3 groups and divide them by 3, that would leave us with just this one group, which we have. So yeah, so we're dividing by negative 3. Dividing by -3 is the same thing as multiplying by 1/3, -1/3. So we're looking for one of those operations, either multiplying by -1/3 or dividing by -3. And we do have a multiply by -1/3. So number 5 is A. Okay, so let's review some of the ideas that we were using today. So what do you do to keep an equation? What do you do to an equation to keep it equal on both sides? Well, what are the things we did today? We added the same number to both sides. We subtracted the same number from both sides. We multiplied, right? We multiplied by that -1/3 in that last one. We multiplied by -1/3. We also divided. We could divide. So multiplying and dividing are related. So we're adding and subtracting. So we divided by the same number. So all these ideas here, we have to remember you do that to both sides of the equal sign. Just like the hangers, we need to remove them or add them to both sides of the hangers. So these are called properties of equality. And the properties of equality say that what you do to one side of the equal sign, you have to do the same thing to the other side. So we're going to write that down also. What you do to one side of the hanger, or in this case of the equation, right? One side of the equation. You have to do the same on the other side. And if you want to write that some way in your own words so that you understand it, that's fine. What you do to one side, you do to the other side.